And now we come to the topic of fluid motion. In this video, we take a look at the concepts of density and pressure. A fluid is a substance that flows and takes the shape of its container. A substance that is in its liquid or gaseous state is an example of a fluid. Regardless of its state, regardless of whether it's a solid or a fluid, a substance may be identified using its density. And there are three densities to speak of. We have linear mass density, which is mass per unit length, m over L, mass of the object divided by length of the object. A variable, Greek letter mu, unit is 1 kilogram per meter. Next, we have area mass density, which is mass per unit area. So, mass of the object divided by area, whether it is cross-section area or surface area. Variable, sigma. Unit is 1 kilogram per meter squared. And we also have volume density, which is mass per unit volume, mass of the object divided by volume of the object, variable rho. Unit is 1 kilogram per cubic meter. Water is a common substance. The density of water is typically taken to be 998 kilogram per cubic meter. Sometimes it is rounded up to 1,000 kilogram per cubic meter for easy recall. But for our course, we will use 998 kilogram per cubic meter. Fluids apply force or influence via pressure. Pressure is force applied or spread out on a given area. This area may be surface area or it may be cross-section area. Pressure P is force over area, F divided by A. This force is perpendicular to the area upon which it is applied. If you have a force applied on an area and that force is diagonal with respect to the area, then only the component of that force, only the component that is perpendicular to the area A, that will contribute to the pressure P. So only the perpendicular component of the force will contribute to pressure P. P is equal to F over A. F unit is newtons. A unit is meter squared. The unit for pressure is Newton per meter squared. This is given its own unit, Pascal, PA, 1 Pascal, unit of pressure. Another unit of pressure is atmosphere, ATM. 1 atmosphere is equivalent to 1.01 times 10 to the 5th power Pascal. Consider a fluid inside a container. The pressure at any point in this fluid depends only on the depth of that point. So say you have this point, depth H. The pressure at this point depends only on the depth H. P is equal to P naught plus rho G H, where P is the pressure at depth H, P naught is the pressure at the surface of the fluid. Rho is the volume density of the fluid. And g, of course, is acceleration due to gravity magnitude, 9.8 meters per second squared. And h is the depth of the point in question. Pressure P at this point, P is equal to P naught plus rho g h. Total pressure is also referred to as absolute pressure, whereas gauge pressure is the difference between absolute pressure and atmospheric pressure. Atmospheric pressure is typically taken to be equal to 1 atmosphere. So, gauge pressure is equal to total pressure or absolute pressure minus P atmosphere, atmospheric pressure. In many cases, for P is equal to P naught plus rho g h, P is the total pressure at depth h. So, P may be referred to as absolute pressure. P naught, the pressure at the surface of the fluid. In many cases, this P naught pressure at the surface of the fluid, P naught is equal to 1 atmosphere in many cases. So, P atmosphere is equal to P naught, which means the gauge pressure, P gauge is equal to P minus P atmosphere, where P is the absolute pressure, is equal to P naught plus rho g h. P atmosphere is equal to P naught. Gauge pressure is just equal to rho g h. So, for many cases, this applies, but take note, not always. So, unless otherwise stated by the problem, for instance, we will take the gauge pressure to be equal to rho g h and the absolute pressure P to be equal to P naught plus rho g h. Particularly for this case, a fluid contained inside an aquarium, for instance. So, for a fluid inside a container. And that's it for now. We'll continue our discussion on fluid motion in the next video. In the next video, we'll take a look at the concept of Pascal's principle. So again, that's it for now. Thank you for watching.